Welcome to Rice 101, module number 7. My name is Griffiths Atungulu, the director of the Hawkins Rice Processing Program. I'm an associate professor and agricultural engineer. My area of expertise is in grain processing and post-harvest systems engineering. I'm housed here in the Department of Food Science with the University of Hawkins Systems Division of Agriculture. In this module number 7, we are going to look primarily on rice storage. We are going to talk about the needs of rice storage, the grain storage ecosystem, problems in rice storage, methods of rice storage, and then at the end of this module, we'll look at some of the rice safe storage conditions in terms of duration and moisture content. Let's look at the need of rice storage. Why do we need to store rice? Number one, rice, just like any other grain or other commodities, is needed throughout the year. And so we need to store it so that we can ensure that continuous supply of the grain whenever it's needed. The other reason why we need to store rice is to overcome processing limitations. What are some of those processing limitations? Our dryers can operate at given capacities, so our milling systems, they can mill at given capacities. And for us to be able to continue with the process, we need to store rice in some good condition so that we can retrieve it for those processes. Now, the other aspect is we need also to ensure that the quality of that grain does not deteriorate over time. And if we store the rice, we are able to preserve things like the kernel intrinsic characteristics as well as the physical characteristics. Another reason why we need to store that rice is so that the farmers or the growers can sell it whenever they need to sell it, when the demand or the market is ripe. This helps them to also stabilize the prices that they can receive from the grain, as well as get revenues that are going to meet the inputs that they already put into producing that grain. The grain storage ecosystem is a very, very complicated system, and we want to look at some of the parameters or some of the factors that are included in this ecosystem. Very, very important are some overarching factors that we may not have much control about, and those are factors that are related with the geographical location of where the grain is being stored. Those factors include things like the wind, the ambient air temperature, the solar radiation, the ambient relative humidity. Those are some of the factors that we do not have control over, and therefore they are going to dictate the kind of storage systems or structures that we are going to erect. And so once we decide the storage structure, based of course on those geographical locations and the requirements of the grain, there are several other things that we also need to look into. Those include the ability of those structures to preserve insect and mites from getting into the grain, microorganisms, as well as rodents invasion into the grain. Now, within the grain mass, there are several other factors that interplay to eventually regulate the quality of that grain. That grain continues to respire, it produces moisture, that moisture needs to be removed. It produces heat, that heat needs to be moved out. And so there are aspects of heat removal, moisture removal, and foreign matter within that grain mass is going to have a big play into how all the airflow within that grain mass is going to take place. And so, again, just to recap, the storage ecosystem is a very, very delicate ecosystem, and it requires a lot of factors to be considered to make sure that that grain eventually is safe for the consumer to utilize. So I've mentioned some of this in passing, but let's kind of delve into a little bit details on the problems in rice storage. The first one here is respiration. Again, depending on the moisture content of that grain, it's a living material. There's also microorganisms on that grain. All these factors result in production of carbon dioxide and heat in the grain itself. Because it's primarily starch, that starch breaks down. And when it breaks down, we have that heat accumulation, we have moisture accumulation with that system. And that can result in changes, some changes in the physicochemical properties of the grain, but more importantly, it can also lead to accelerated growth of microorganisms. And then we also have the aspect of dry matter loss that comes in because of the grain breaking down. And so we need to be concerned about that so that respiration is minimized as much as possible. The other aspect we need to think about are rodents and insects and birds attacking our grain. The other thing is we need to be conversant of the ambient temperature conditions so that they do not re-wet the grain, because for rice, when it gets re-wetted, then we have fissuring happening within those roast kernels. Over-drying, when the conditions within that grain are such that the moisture content of the grain is going to go below our recommended market moisture content, then we are faced with over-drying situation that can lead into loss of revenue to the grower, as well as even changes in some of the functional characteristics of the grain. Let's look at some of the storage structures. Within the US, primarily rice off the field is stored in silos, or sometimes called bins. And what you see there on your left is a metal bin, and they vary in sizes, ranging from 20 bushel bin, 50 bushel bin, and on above. Then, in addition to metal bins, we could also have concrete bins. Again, this may also vary in size and they vary in cost of erection as well. Now, there are cases where we might be able to store rice in flat warehouses. This is not a common practice, especially in the Mid-South regions, primarily because our temperatures and our relative humidities are not very, very friendly. And then the insect burden and so forth are not very, very friendly for this kind of systems. They require significant aeration needs. When that rice is not properly stored, you will expect a lot of physicochemical changes to kick in, which could be very detrimental from an end-use functionality standpoint. Number one, the changes in rice color. There could be milling characteristics that could change. There could be cooking characteristics, which are very, very important for consumers as well as end-use processors. And when I talk about cooking characteristics, I'm talking about some of the pasting attributes of that rice when it's turned into flour, water absorption characteristics of that rice, volume expansion characteristics of that rice. Those are very, very important if we are going to utilize this rice eventually as an ingredient, or we are going to utilize it as a flour to formulate any other products. Could be expandable products, extruded products, and so forth. I wanted to take some time to kind of show you some of the kinetics that come into play when rice is stored at different conditions, particularly looking at the impact of different cultivars, storage temperatures, storage duration, and moisture content. This slide here is showing us the rough rice storage versus the milled rice color. Again, this is from an experiment that we have conducted here in the lab. You can see the changes in moisture content. This picture is captured for rice that was stored for about 16 weeks. Very clearly, you can see that as the storage temperature increases, the vulnerability of that rice to discoloration also increases. As the moisture content increases, again, the vulnerability of that rice to discoloration at specific storage temperature also increases. Very briefly, I would like to say discoloration varies with cultivar and also seasons. Different cultivars present different vulnerabilities to discoloration. And again, season comes into play because depending on the prevailing temperatures during growth, the rice might come with different abilities to withstand some specific stresses in terms of temperature and moisture content. Now, we have realized, therefore, from these kind of studies that the cooling to temperatures of about 10 to 15 degrees Celsius may maintain the kernel color if we store it at moisture content that are below 19% for up to about 16 weeks. We, therefore, recommend that the use of coolers might be very, very important, especially if we are going to combat some of the effects of the field heat that is put on the rice during storage. Next, I want to kind of explain a little bit some of the kinetics that are involved, especially when we store rice at different moisture content. What are the discoloration patterns like at different moisture content and at different temperatures? Very clearly, we can see from this figure that show a test that was done in 2014 and 2015 for the same cultivar, CLXL75. This is a long-grain hybrid cultivar. Very clearly, we can see a very, very significant influence of temperature here. We can maintain that grain color significantly if we reduce or minimize the storage temperatures. 10 to 20 degrees Celsius would still maintain the grain color significantly all the way up to 16 weeks. For both years, we see the same result. Now, in the next slide, I'm showing the same rice, but now at different moisture content. This is at 21% moisture content, same cultivar, 2 seasons. You can clearly see that when the moisture content increases, you start seeing discolorations even at lower storage temperatures. From these sets of figures, it's clear that for us to have that rice not change its color, we need to store it under cool environments. 10 degrees Celsius, 15 degrees Celsius would be ideal. And so we don't recommend storing high moisture content rice at temperatures that exceed 15 degrees Celsius, because that evidently is going to induce discoloration. The next aspect I wanted to explain is the headrise yield, a very, very important parameters for the growers. It shows how much rice eventually comes out as whole rice. What we see from these figures, it's not significantly influenced by the storage temperatures for a considerable duration. And we can say clearly from the range of temperatures that we studied and for the range of moisture content that we studied, we can say that the headrise yield are preserved with storage at 10 to 20 degrees Celsius all the way up to 16 weeks. So they are not affected significantly until other storage parameters start being affected. Now, in this slide, I want to describe to you a very important property, and that is what we call the viscosity. Viscosity kind of gives us an indication of how this rice is going to perform during the cooking process, and kind of gives us some indication on how this rice is going to absorb moisture or change in characteristics, especially at different temperatures. What we see in this is that indeed, depending on the different temperatures, we can have different profiles. And without going into so much details, this profile gives us information about things we call peak viscosity, our setback viscosity, and final viscosity. Those are very, very important. Now, if you look at these profiles of rice that are stored for 10 weeks, and again, this is for low moisture content rice, we see variation in profiles based off of temperatures, which kind of tells us that there's a very, very significant correlation between the storage, among storage temperatures and the viscosity characteristics of rice. Same thing was observed when we store rice which has higher moisture content, the same rice at higher moisture content. We see variations in viscosity profiles as a result of storage temperatures. Again, we can see that rice that was stored at 27 degrees Celsius tended to have higher peak viscosity, and rice that was stored at 40 degrees Celsius tended to have lower viscosity. So in short, I would like to say that, when it comes to rice functional properties, storage at 27 degrees Celsius maximizes the peak viscosity. Storage at 10 degrees Celsius and 21% moisture content maximizes setback and minimizes breakdown viscosities. Now, there's something we call aging that happens within the rice, and it's a very intricate phenomena that starts pre-harvest, and most of the time it's dependent on the temperature at which the rice is stored and also the moisture content at which that rice is stored. It's complicated because any changes in the lipid and the protein and the starches that are within that rice are also going to affect its functional characteristics. And so, of course, those profiles shows us that aging phenomena that is playing as a result of rice being stored at different conditions. And so what we observed from those slides also is that storage at 40 degrees Celsius initially increases and then reduces the peak viscosity during storage. So it's very important for us to realize that our storage conditions, that means the temperature, the moisture content, and the rice moisture content are all going to influence the rice functionality. Now, looking at all that result that we've just described, it becomes evident that cooling would really play a great role in preservation of that rice. And so we've recommended some strategies to cool rice so that we can have better quality of that rice during the storage. And what I'm showing here is a commercial rice cooling system. In this commercial rice cooling system, first of all, aeration fan suck ambient air through a dust filter. Then air is then cooled or conditioned to desired temperature. And during that process, some water in the air condenses, thereby dehumidifying the air. That dry air, when it's supplied through the grain, therefore is going to remove some moisture from the grain as it cools the grain. Now that process technically is called conservation cooling and drying. And in the next slide, I just want to demonstrate to you some of that. But before that, let me show you this figure here, which shows you a commercial cooler that is attached to a drying bin. You can see on the left there the ducts that are pulling air, ambient air, passing it through the cooler, and then that air is processed and then pushed into the bin. So how does a commercial cooling system really work? First of all, let's look at the grain coming in at a higher moisture content, 23%. That's our bulk intake moisture content. We recommend, first of all, that grain needs to go through a first drying step to remove some moisture. When it's coming in from the field, typically in our area here, the temperature is about 35 degrees Celsius. And so that cooling is going to bring that temperature from 35 degrees Celsius to about 15 degrees Celsius. The cooling process removes moisture, and therefore that grain comes to about 17% moisture content. It's at 17% moisture content and it's cool at 15 degrees Celsius. At that condition, we can store it. During that time, the process of respiration keeps going on, and we expect some heat accumulation within the grain. Because of that heat accumulation, we need to cool the grain again. And so you have the need for second cooling, but before that, we can do a second drying step, and then we do a second cooling, and that second cooling is going to reduce the moisture content significantly, and so we are able to come down to about 14% moisture content of the grain. So the grain is at 14% and it's at 15 degrees Celsius. At that point, we are able to store that grain for a very long time, and also we are also able to take it through a milling. If the storage is going to be for a very prolonged time, we expect the temperatures to be increasing, and so there might be need for further cooling. Now, the next slide here, I'm showing the safe storage moisture content of rice. Now, depending on the storage duration, we recommend different moisture content levels. If you are going to store that rice for weeks to a few months, then 13 to 14% moisture content is okay. Now, during that time, because of the high moisture content, there are potential problems that we are likely to run into. For example, we are likely to have mold, discoloration, respiration loss, and also rewetting may occur. And therefore, we recommend that at these conditions, we install some aeration fans that can help remove some field heat and also remove any possibility of mold growing within our rice. Now, if you're going to store that rice for 8 to 12 months, we recommend that we store that rice at about 12 to 13%. During this period, we need to be concerned of things like insect damage occurring in this rice. If you're going to store that rice for longer durations, 1 year and above, then the respiration is going to be very, very minimum. We would expect, however, problems of loss of availability to be of concern to us. Now, the next slide here, I'm showing the safe storage duration for rice. And before I explain this diagram, I would like to say that these safe storage durations are based off of 0.5% dry matter loss. So what that means is during grain respiration, the starch is being broken down, and that breakdown of starch results in some changes in the weight of the grain. Now, it's been determined from research that 0.5% dry matter loss represents a significant quality deterioration, and therefore it has become a marker of safe storage duration. Now, you can see from this chart here, we have moisture content ranges, and we also have storage temperature ranges, and then within that, we have the safe storage durations. When the rice comes off the field at 21% moisture content, if we are going to store it under ambient conditions, about 77 degrees Fahrenheit, which is about 25 degrees Celsius, we have about 5 days before that grain dry matter loss exceeds 0.5%. If that rice came in at 16% moisture content, or if we are able to dry it immediately to 16% moisture content, we have quite some room, about 20 days before we see significant deterioration below 0.5% dry matter loss. Now, from this chart, you can see that if we, on the other hand, stored that rice at very, very lower temperatures, 41 degrees Fahrenheit, about 5 degrees Celsius, even the high moisture content rice, which was at 21% moisture content, has about 40 days before it really falls below 0.5% dry matter loss. If it's dried further to 16%, then you have a lot of time before you can exceed that 0.5% dry matter loss. Now, with that said, I want to leave you with a few references that you can go into and dig more information to kind of complement some of the information that I've provided in this module. Thank you very much for listening to this module, and I look forward to talking to you in the next modules.